the Czech Academy of Sciences. So a little bit about Peter. Peter did his PhD in Germany before moving to ISO Chile, where he was there for 4 or 5 years, first as a fellow and then as a paid associate, before returning to the Czech Republic, where he's originally from, as a kind of representative of ISO, before becoming the head of the Exoplanet group at the Astronomical Institute of the Czech Academy of Sciences. And he's the first short-term visitor of the Erasmus Plus program that Jorge and I are representatives for the IAC. So over the coming 2 years, we should have many more visitors like Peter, but Peter is the first because he is the leader of the project. So please, Peter.
Okay. Thank you very much, Dave. Thank you very much for your introduction, and thank you very much for inviting me here and to give me this opportunity to talk about what we do in Ondřejov. And I will also try to speak a little bit about the Erasmus project because that's a possibility for exchanges. And then about the summer school, which we plan also within the Erasmus project. So at the beginning, I would like to start with the science. So you see here our telescope. So this is the 2-meter telescope in Ondřejov. It's the Zeiss telescope. There are more exemplars of this. There are twin telescopes. And in this talk, I would like to convince you that we really need 2-meter telescopes, even if they have a little bit older instrumentation, but still that we are capable of doing some nice science. So basically the motivation, I had this slide for my PhD defense in 2009, I think, and that was when I worked a little bit also with Corot at DLR Berlin. And then there was a great need of ground-based follow-up. Of course, for Exoplanet, the ground-based follow-up is needed as radial velocities, and for Corot, there was also a special need for photometry, as Hans can say here, because Corot had these little prisms, and the PSF of the star was really huge, basically, and then you needed to eliminate false positives. So there was a really lot of follow-up observations needed. And this is also the motivation for all those 2-meter telescopes, or this even a little bit smaller telescopes, because now we have TESS, now there are first batch of candidates from TESS. So we will be needing plenty of radial velocities, even though, okay, the first ones are in the south, but there will be northern targets coming. And then, of course, there might be some need for photometry as well, and monitoring. And in here, we can contribute very well with the equipment which is already working or which is operational. So this is only where I started. I started on a small telescope, so this was our toy at Cerro Armazones, and this was basically we were doing some photometry of the Corot fields, and well, Cerro Armazones with ELT is somewhere here. So then I moved to ISO, as they've said. There I was working a little bit with Hawkeye, which is a near-infrared imager, and so what I was doing was that I was trying to defocus the 8-meter telescope to be able to observe exoplanets, which is of course unusual, because if you have such large telescope, everybody was asking, why would you like to defocus this? Why? But it worked. So, and then, okay, so after the motivation, as said in the first part, I would introduce you the Ondřejov SL spectrograph and what we are doing and our first results after the science verification, basically. Then I would like to speak about our new project, which is called PLATOSPec, and that should be dedicated, there should be a spectrograph dedicated to Plato candidates follow-up. So, briefly about the institute. So we are the largest institute in the Czech Republic, so we have about 120 science staff. Well, there is a department operating the 2-meter telescope, which is equipped with spectrographs. There is no imager. And the main topics are, of course, from the historical reasons, variable stars, solar physics. There is a group dedicated to some galaxies research, And we are also having a group which is working on theoretical models of black holes. So we are involved in Solar Orbiter. I think also in the Solar Telescope, which you have here, and then we are trying to get involved now in Plato Space mission and also in Ariel. So, just for you to know where the 2-meter telescope is, so, well, you land here when you come to visit us, and then somewhere close here, so like 40 kilometers to the southeast, there is the little village called Ondrejov, and there is a 2-meter telescope. So maybe well, for those who have kids, maybe sometimes you saw in the continent there are sometimes, well, of course in Czech Republic, but I think I saw in Germany as well, there is a book and these paintings about this cat who was speaking and going around the world. So there is also a link to exoplanets, which if you go to our institutes, there is a frog, and if you know our Czech poet Jan Neruda, then that was a poem about the frog teaching, about the old frog teaching the young frogs, and the young frogs were looking at the sky and they saw the stars, and they were asking the old frog if there are as well frogs like we are here. So that is the first link to exoplanets. But then the telescope, the 2-meter telescope, is here in the forest. For those who saw the first size telescope, which is located in Tautenburg in Thuringia in Germany, so we are basically really the twin telescope, and the location is also very similar in the forest. The weather pattern is very similar. There is the old observatory here. So okay, detail. Okay, so now about the group. So basically we started, so I came back to Czech Republic in 2015, but then we had a problem with the telescope, and it was quite some other work, and then the group started really with some observing with the OS, so which is our Ondřejov spectrograph. It started in 2017, and since then now there are starting new PhD students. We have 2 postdocs, one in maternity leave, and then of course collaborations. So the telescope is here. You can see it's well, the diameter is 2 meters, and then it operates through Coude focus, and then the light goes here through the leg down to the Coude room, and then there are 2 instruments in the Coude room. It was inaugurated or opened in 1967, and as said, it is the twin of the German telescope. So we have an Eshel spectrograph, which I will be speaking about mainly. The Eshel spectrograph was basically built in 2005-2006, but then there was no one who was using it because people retired, and due to the staff of the observatory was doing something else. So that there was not much use, and then only when I came, then of course I started to work with RTHs in Tautenburg, and then this is great, which I hope I will convince you, this is a great instrument for radial velocity follow-up, especially now for tests, because there will be plenty of bright targets. There is also another spectrograph, there is a single order spectrograph, but this is used, I think, for the line profiles, and colleagues, you're using it for variable stars, for hot B stars. So regarding the weather pattern, of course, it's not like here or at ESO, but still we have some decent coverage of the observing time. So you see the red lines is the time when it was observed. The gray time is the observable, or time which could be used for observations. And you see that, okay, there are of course patterns of bad weather, so there is somewhere it was just open for a few hours and so on. But then the best observing time is during the summer period, but of course the shortest. And in total, if you look at numbers, so we have something like 20 to 30% of nights per year. That means, let's say, pessimistically 90 to 130 nights. It might be not that much, and you might say, well, okay, it's not that much, but during these nights we can observe, and the time is ours. So the thing is, if I would like to have the particular date for observations, I write to our secretary, who works as a TAC or OPC, basically everything together, and then usually I get all the time I need. So in principle, we have this 90 nights for us. Okay, the weather pattern, as I said, this is very similar for Tautenburg. So again, 20 to 30%, and I think we are not that much worse than Haute-Provence. They have, I think, 40% perhaps. So what do we have? So we have now we go to OS, to the Escher spectrograph we have. It was home built, so it is not kind of harps, but I think the quality is quite nice, and you can do quite nice science with that. So the detector is 2K by 2K, so we can go from 370 to 850 nanometers. Basically, in the red part there is of course fringing, but it can be quite nicely removed. So the resolving power is about 44,000. And now about the RV accuracy, what is of course important for the follow-up. So we can get down to, let's say, 10 meters per second. In Tautenburg, well, we have an iodine cell, which is borrowed from RTHs from Tautenburg. And in Tautenburg, they showed with very bright star, I think it was Beta Gem or something like that, they were showing the accuracy with iodine cell of 2 meters per second or something like that. So, but of course, for bright objects. The limiting magnitude is, well, okay, with 12.5 magnitude star, we can get signal to noise 710 in 1.5 hours exposure. So, of course, there are some limitations, but we are working also a little bit on this limit. But let's say 10th magnitude we can do quite nicely. I will show you then the accuracy on the data. So as said, the iodine cell is borrowed from Tautenburg, so you can measure with or without iodine cell. The only problem now is that there is through CUDE, the light goes, there are 6 surfaces, so we are now trying to exchange it for fiber. Of course, there will be another problems with fiber, but still. The performance might improve a little bit in 2019. That's planned for next year, basically. Okay, so here you see the CUDE. Okay, it looks like one tube here. There you go to the other spectrograph, to the single order. This goes to OS. The telescope is then up here. This is basically the kind of IKEA-looking spectrograph. Well, relatively simple design. Collimator, Escher grating, the detector is here. So here is the detail of the detector and the Escher grating. And then this is what we can get on the wavelength solution. And now here is an example of the spectra. So from blue to red, so there is the fringing, but you can get rid of that. An example of H alpha. So, but what is more interesting, of course, is the stability of the instrument. So this is we measured some, this is I think the 5th or 6th magnitude star. So we measured for a few nights, so 5 nights, May, June period, so let's say 3-4 weeks, we can go around 100 meters per second. Well, I think it was even better. This is one of the preliminary data, so we have now more measurements. But let's say 10th of meters per second. So the long-term stability, okay, so of course this is 1 year, so we don't know what's happening here because there was some technical problems and so on, so we didn't observe. But in principle, again, the star observed and checked for the accuracies. We can get, let's say, for few hundred meters per second. This is of course not sufficient to characterize all the hot Jupiters, but it is very sufficient to do the ground-based follow-up. So what we can do some initial screening of the candidates. So basically the space mission provides you with the candidates, so we can do spectral typing, let's say. We can reject false positives, we can check for binaries, and then we can, of course, characterize some of the Jupiter-sized planets as well, with those with high amplitudes in radial velocities. Okay, so this is one example. So it was a little bit difficult. So for our first, once we started to use the spectrograph, so we selected some K2 candidates, but of course K2, there were not very good candidates for the spectrograph because some of them were just faint and we couldn't do much, but there were some, but of course they were binaries, as you can see here. Even though this binary, I think, is kind of interesting binary, there is some variation in hydrogen lines, and there are some ideas that there might be some disk and some small object. So it might turn out to be a quite nice object. Then, okay, there is a great SB2 binary, which of course is not a planet, but well, this we can do. So this is from K2 again. And then there is an example of the iodine cell measurement, which was reduced by ARTI, but this is data from our telescope. I think it's Sigma Draconis or something like that. And you see the scatter is 11 meters per second with the iodine cell. So we can measure, so the brief summary of this, we can measure, let's say, around 100 meters per second. So, but we can go down to 10 meters per second with iodine cell. So we can cover quite nicely also the short periodic planets. Then, of course, we did some 8 hours exposure. And then when you put all the frames together and you make it the 8 hours exposure, so I think on the 5th or 6th magnitude star you can get to 20 meters per second without iodine cell. Long-term stability is also for such type of instrument is not too bad. And then what we can do is I said. So from the point of view of observing program, we cooperate with Tautenburg, so we have some common targets. We were looking for some A stars which were thought to have planetary candidates. And then of course there will be now test follow-up, and then also we are now investigating how we can use this small size telescope for exoplanetary atmospheres, and then I will show you that we can, of course. This is that we can't wait for tests, and then we are already looking forward for the more northern targets, because in the first batch I think there was even one target which was 5th magnitude, so this is exactly, okay, that was only one star, but you know, from next fields there will be many more, there will be tens to come, and hundreds, and then I think that will be where we can contribute. So we also collaborate with some amateurs who provide us with the data. Okay, this is very I'm pessimistic about this, but still it was a nice candidate showing kind of a grazing eclipse, so extremely grazing eclipse. There are not so many, I realize there are not so many extremely grazing eclipse exoplanets, and if that would be one of them, that would be quite nice. It seems that it might be something like this, but okay, this is to be confirmed, so we have to do some spectroscopy. So about the atmospheres, you know perhaps this image, so this was done by Wittenbach, and this was done on HARPS for the HD 18973-3B. And what you see there is the comparison. So they took basically the series of spectra during the transit, before, in, and out of the transit, and they compared them. So this is around the sodium doublet. They compared the spectra, and basically these lines, this is the sodium coming from the planet, because they divided out and in, easily said. They divided those, and then what was left must be from the planet. Okay, this is of course in theory easy, but you have to remove tellurics and so on, but it looks convincing. So the peak is about 0.64%. So what we did, we had some time with Pharos, but unfortunately the Pharos had the fixed window, so we had to select the planet which was transiting that fixed window, and that was WASP-18. That was the only one which was transiting very hot Jupiter-sized planet, and we just were curious what we can get for the Pharos transmission spectroscopy. Again, the same spectroscopy in and out of transit. And then, okay, this is around sodium doublet. There is no detection, of course, but the point is, if you look at the scatter, well, the bin scatter, so we are at 0.17%, and then they detected with 0.64% sodium on a different planet. And now I was speaking yesterday with Henrik Payen, who told me that they even detected much larger contrasts. So in principle, I think what this can show is that if you do properly the telluric removal and you treat the data properly, then in principle you might be able, and you select good targets, you might be able to do even some exo-atmospheres with mid-sized telescopes. Okay, so we also look into the archive. This is with the large telescope, but just wanted to show that we are looking into the archive in some secondary eclipses with Hawkeye, because there is a plenty of ESO data which are not reduced, so then we try to, we want to kind of understand what happened if just people didn't have time or the data is bad quality. So this is really huge correlation with seeing there should be secondary eclipse here, but okay, so this is not a good data set definitely. So this is what I already said, outlook for OS, that we are looking for tests, but then we are planning also another project, because I think these 2-meter telescopes with the current instrumentation, or whichever small telescopes where you have all the time you need, they will be extremely needed. Everyone is looking at espresso, which is great, of course, and everyone is looking at large telescopes, large facilities, but you have to compete for time, you have to get the time, and okay, if the rate of false positives was for Kepler, I think K2 was 80% for Jupiter's, then okay, you would be wasting a lot of time. And for this, you can use the smaller telescope which exists, or the new ones, well, not the new ones, but with new instrumentation, which we are planning in this case. This is the PLATOSPec, so this is the old 1.5 meter ESO telescope, which was basically idle for some time, but now ESO made some tests and they checked the status of the telescope, so it is alive, it can move, it needs refurbishment. And so we thought that we might put a spectrograph on that and do the, as the name says, so do the Plato candidates follow-up. Because Plato will be observing basically 1 million bright stars, so there will be so many candidates, and the stars are from the 5th till 11th magnitude, so we can cover the whole range. I will show you later. So now we have a little PLATOSPec consortium, so which is now, well, we are led in Ondřejov, but then we work with RTHCs in Tautenburg and Universidad Católica de Chile, represented by Leo Vanci. Maybe you've heard about Fideos spectrograph. So Fideos is mounted on a 1 meter telescope, and they can achieve, let's say, I think Leo said 4 meters per second on 7th magnitude star, something like that. So the status of the project is that it was ESO said it's okay, go ahead. So now we have to, of course, find the funding, which we submitted some proposals. And the idea, of course, as I said, in 2026, the Plato Space mission will be flying, should be flying, and we should start to get many candidates. Of course, we will have also some candidates from TESS, but the project, well, TESS started now, so it will take us still a few years to build the spectrograph if everything goes well. So with TESS, we will have only little overlap. So the main reason is Plato. And again, the idea is to have the, let's say, 300 nights, which we will have. So something will be for Chilean time, 10%, and something will be the bad weather. But in principle, we will have 300 nights on this telescope. And as you saw in case of a telescope in mediocre, well, in not optimum location, you saw that you have 90, 100 nights, and you can do basically the follow-up, and you can do even maybe some atmospheres. So I believe that might be possible also here. Okay, so this is the telescope. As said, it's one of the first telescopes, so it is perhaps the same age as is our telescope in Ondřejov. Some people say, okay, it's old rubbish telescope, but that's not true because our telescope works perfectly fine and there was no really major downtime. There was a problem with the mirror, but that was because of the recoating company. So, but the mechanics of the telescope works fine. So there is no reason why this telescope should be worse. And then here, as I said, the motivation. So this is the range of Plato. So here is the magnitude, which will be the range of magnitudes observable with targeted by Plato. And as said, it will be 1 million of these bright stars. So the motivation for us was not that we want to compete with HARPS and to look very small planets and to get Earth and so on. But the motivation was really to do the initial screening, to get the stellar parameters. Of course, there can be stellar parameters. Gaia helps with this, but still, I think you need spectroscopy. Then we can again reject false positives, and then we can characterize hot Jupiters, because we plan to have the radial velocities around 5 to 10 meters per second in the whole range. So this should be sufficient even for some smaller planets. And so maybe also even this exoatmospheres for very bright targets. So I think this would be our niche to go to Jupiters, but to be also involved perhaps in the detection of the small planets, because, well, the time at the large observatories is expensive, and even though, of course, people will have the detection of the second Earth and confirmation with Espresso or ELT or whichever large telescope, but they might need perhaps a smaller telescope before. Okay, this is only to say which cases of false positives there are. So you can have various eclipsing binaries, background eclipsing binaries, brown dwarfs, and well, there is written about the false positives. And then one more thing about the motivation for the project. So this is from official numbers. I don't know if that changed or not, but I found somewhere this from Stefan Ondřejov. So he was making an estimate of time needed for the, and I think it's in the Plato Red Book, so that the estimate of time you need to fulfill the mission goals and so to have the radial velocity follow-up. And for 1 to 2 meter class telescopes, you need basically 50 nights a year for 6 years, which was the mission time. So, and I think what I've heard, this is the rather lower estimate. So perhaps it's more optimistic. So you will need perhaps much more time than this on 1 to 2 meter class telescopes. Okay, so then the others, of course. Yeah. Okay, and now the definition of the spectrograph. So we would like to go from 360 to 680 nanometers. We wanted to have the calcium lines to check perhaps the stellar variation. The resolution should be 70,000, the resolving power. And then I said, okay, I said, well, Leo was standing to say 5 to 10 meters, whereas Arti was saying we can achieve 3 meters per second in radial velocities in the whole range of this 5 to 11th magnitude. So let's say something between 3 to 10 meters per second. And then, okay, we would like to have the simultaneous calibration and also the option of iodine cell. Here now we are in kind of a design phase. So the spectrograph is designed by Leo Vanci, so here's just an example of the echellogram. And now we are trying to fix the other parts like front end and calibration unit. So this is a little bit optimistic schedule. So we said that the project basically, okay, it goes for 2017 when it started, the discussions. Let's say 2022 should be finished, but I would rather say 23, maybe even 24. It depends on the funding proposals. It depends on many things, and how long does it take to, of course, set up the spectrograph then in Chile and all this logistics aspect. So, but of course, if it would be 23, then we might still be quite useful for tests. Even 24, I hope that tests will be flying longer than planned. So some people said that still when Plato flies, then tests might be flying around. So that would be, of course, great. And then, okay, so we can start to work. I don't know how the field definition, what I understand from Plato, that's a difficult process, but I understood that the field should be defined like 2 years, latest 2 or 3 years before the launch. So basically, that's the time when we should be operational as well, hopefully, if everything goes well. So far, the plan. So let's hope it works out. The summarize the goals of PLATOSPec, the follow-up, then the initial screening, characterization of some hot Jupiters. Then this is an interesting thing. Of course, it depends on the long-term stability, but the point is that on this kind of telescopes, you can do long-term monitoring, which you cannot do anywhere else, because it's simply impossible to monitor some object for years. This here you can do. Of course, for example, for Jupiter, I think Jupiter from our solar system, you would need 10 meters per second stability, but okay, if you can reach that, then you can. And then we have also a web page, so you can have a look at our web page. It's still basic, but we are trying to put in things there. And we will have also a PLATOSPec meeting where we basically our consortium will be discussing the next steps. We are also looking for partners. If someone is interested, of course, then yeah, we will be happy to collaborate. So this is pretty much about the science. So again, I would like to say, I'm repeating myself, but I think there is not enough of repeating that the 2-meter class telescopes will be more and more interesting, or they are more and more interesting for all the space missions, or at least in exoplanetary science. And I think people should be using them. When I came to Ondřejov, so there was a discussion, shall we close the telescope, or why do we have the 2-meter telescope, shall we use it, I mean, it costs money and so on. But I think exactly this, that you can offer plenty of time, you can offer long-term monitoring. This is why the telescopes should be used. And basically, they can be operated for some reasonable cost. You don't have to invest huge money unless they break, of course, but they usually, the Zeiss company did a very good job. So I think we have a job to do for next years. So I hope I could convince you. Okay, then that was science, which we are starting, and now a little bit about what we are doing, what has something to do with the Erasmus project, why I'm basically here now working with Dave, and then, okay, this one day visit with Jorge. So we basically organized a few summer schools in Czech Republic. This was the first where Dave was tutoring a group of students. That was 2015 in Brno. It was the kind of summer school, the neon, like it's organized here, or the winter summer school. And then we try to keep on with a small format, so we try to have one every year. So this is, we are trying to encourage people, of course, mostly from Central Europe, to get to larger instrumentation, to encourage them to use ESO or other options. And that was also the motivation. Okay, sorry, that's about the workshop for PLATOSPec. So we are trying to organize we are organizing the workshop on the 29th, 30th of October for the PLATOSPec. So if someone would be interested, of course, you're welcome to come. And then, okay, back to Erasmus. So we are trying to encourage. This was the whole idea of Erasmus project. So which we have with Dave and Jorge. And with other institutes. Basically, it's a project with IAC, Slovak Academy of Sciences, University in Bratislava, and Masaryk University in Brno. And this project has to promote the career training of young scientists and also exchanges for short term for experienced researchers. So there are those two aspects. One is the students or postdocs, young postdocs, and the other one is the short visits of experienced researchers. So basically the long-term exchanges, which can be from 2 months till up to 1 year. So there are calls and there is a competition. So there was first call was last year, so that's closed. We have already candidates and people are coming, so some people already came and left. So now to IAC, there will be people coming from IAC to Czech Republic and to Slovakia. And then there will be another call. So if someone would be interested for the long-term mobility, we will have the call open perhaps December. This we have to discuss today. How to organize it, but the call will be open perhaps December, closing around the new year, basically. And then the selection process is very quick, and then once you get selected, then in principle you can plan your visit. You can choose one of the partner institutes. So, okay, we cannot offer the big facilities, but we can offer collaboration. So that might be if you are a student or a young postdoc, then it might be collaboration within the groups. Or we can offer maybe joint project if you, for example, need the small telescope for something. We are happy to help with this, so this can be organized. And then, of course, for the Czech and Slovak students, it is when you would like to supervise someone, then again, that would be great if you send an email to me, Dave, or Jorge, that you are interested, and then perhaps you might end up with a student coming here for 2 months to 1 year. Then for the short-term exchanges, if you would be interested to come to Czech Republic or to any of the institutes, then again you are encouraged to contact Dave and Jorge and say, okay, look, I would like to come to this institute. It's up to 21 days. And of course everything is paid so that you get daily allowance and the tickets are paid. For the short term, for the experienced researchers, we would like to have from you, well, you should give them the lecture for students and maybe do some talks or seminars for students. Of course, this is just to promote the career enhancement. So what is then also, we said that we have to organize 2 summer schools. So the first summer school will take place at Slovakia from 18th till 27th June 2019. So it will be aiming at PhD students mainly, but also some master students which are advanced can come. Basically the format will be groups led by a tutor, working with some archival data which the tutor provides. I don't know, let's say an example, the tutor will have a data on exoplanetary transit, so then it will be about the analysis and about how to do the photometry of the exoplanetary transit, and then the people will present it like at the conference. So, and then the last 2.5 days will be about proposal writing. So if you or you know that someone would be interested to come as a student participant, then that would be great. Tell them there will be announcement, will be of course a little bit later because we are fine-tuning details, but the dates are fixed. And then we have another thing which is mainly for postdocs. We need tutors for the projects, so if someone of you would like to have, we can also discuss this during the questions, which will be right now because that's all what I have to say basically. So if someone of you would be interested and would have a project which you would like to work with the group of students, we would be only happy that you help us. And for this we would of course pay your trip, pay your stay at Slovakia, and well, we would be very happy that you help us with this project. There are also web pages of this which are erasmus.asu.cz. I can show you the web page, and then that's it. So, okay. So thank you very much for your attention, and if you have questions. Thank you.
Questions? Are there questions? No one? Everything is
Lunchtime,
clear?
right?
Okay, so maybe you can discuss with him directly if you have got, yeah.
Besides Plato, do you have any other science objectives foreseen for this telescope?
For the Plato you mean
yeah.
for both? So
PLATOSPec I was thinking now, but you could talk about both.
yeah. So besides, so for the Ondřejov spectrograph, there will be of course now the test, and then later Plato as well. And for the PLATOSPec, the main objective is Plato, but I believe Ariel will be also, if everything goes well and is then approved everything, then I think for Ariel we can contribute as well.
NGTS, next generation.
Yes, indeed. About NGTS we were also discussing, but I don't know how is, because, well, Plato was the natural choice, of course. But yeah, sure.
Well, I just would like to mention, a very nice talk, just would like to mention that with the 3 meters per second and the position on Lycia, you would be in a perfect spot for multi-site campaigns on seismology of bright targets.
Yeah.
Just wanted to mention that.
No, okay, so this is, I mean, so for me, the main motivation is, of course, planets and RV follow-up. But in principle, this is also one of the reasons for the PLATOSPec workshop, that we would like to make this workshop so that people present their science and what they could do with PLATOSPec. And of course, if there is astroseismology, yes.
Because
Great.
light red giants, they
Yeah,
oscillate on
yeah,
those
yeah.
on those
Yes.
regions, and you can actually provide months of time base for that.
Exactly. Yes, this is exactly that's if there would be interest in this, we are happy. So for sure. Well, there was even at the ING I was speaking about this, and they were speaking about polarimetry. So okay, this is another point, because then you need, well, I don't know if 1.5 meter telescope, if it is not an overkill a little bit, but the point is that you would need their larger budget. So this is another limitation. But in principle, everything is open. Yes.
Someone else wants to ask something? No? Okay, so let's thank the speaker again.
Thank you.